Okay. Good morning, everybody. What do you? Negative don't need those, yeah? Come on. Right. Mm. So why don't you occupy this particular column? I have a question for you. Why don't you, you don't have to leave a big space like that, no? Right. Uh, okay. So, the subject we are going to learn in this class is combined math. Okay. If you take some subjects like history, or I would say English, uh, social studies, those subjects are everywhere. Like, say, for example, say there are 220 countries. In every country, you can learn those subjects. How many countries are there which teaches you combined mathematics? How many countries in the world? There's only one country, that is Sri Lanka. There's no subject usually called combined maths because in A levels, you have pure maths and applied maths. That's what we had long time ago. Like chemistry, I'll just say the history about this, history of this, physics, then pure applied. In 2000, they combined these two because, in 1987 to 1989, there were, it prevailed JP insurrection. A lot of people lost their lives. So the government appointed a committee to see the reason for this. Like that's called the Taruna Asahana Committee. The reason for the unrest of youth. So they came up with some recommendations. One recommendation was that they recommended to reduce the number of subjects in A levels. So they had to reduce these 4 subjects to 3 subjects. However, there were only 2 faculties of engineering at that time. So they demanded, they wanted chemistry, physics, and one of these. Little bit of, a subject which contains little bit of pure math and little bit of applied math. Simple parts. So that's how this, the subject combined math emerged in 2000. Similarly, the universities we have in Sri Lanka, like they are usually, their rank is like below 1,000, like say 1,200, 1,500. If you take any department in those universities, they are also ranked like that. However, the department that I work, that is, again, it has a funny name, engineering mathematics. It is in the University of Perera, engineering math. Now, our world rank is 2. What is the reason for that? The world rank of our department is 2. There's only one department better than this. But if you take the department of history or department of chemistry in science faculty, its rank is about nearly 1,000. But our rank is 2. What is the reason for that? Because there are only 2 such departments in the world. Right? That is the reason for that, right? For example, say you take part in a race where the number of competitors is 2, right? So at least you can secure the second place, right? So that's like that, right? Okay. So combined math is the only, Sri Lanka is the only country which offers you combined math. Right? Okay. So we need to, to get into an faculty of engineering, you have to do chemistry, physics, and combined math. Or if you want to learn like computer science, still you can go with these three, or you can take IT, physics, and combined math. Hmm? Now, these days, apart from civil engineers, other fields like thrive. Like they are, I mean, like if you go back and see what happens to a graduate of engineering graduate 10 years back, probably their salary is like similar to doctor's salary, like salary of a doctor. But now it is different, right? Now some engineering graduates straight away go to certain positions where they pay nearly 1 million. The doctor cannot earn something like that. But usually computer engineers secure those type of jobs. Hmm. And now things have been changed. Like long time ago, no, not long time ago, I would say 10 years back, uh, our engineering graduates, means mainly Morato and Peradini, they go for higher studies, like in USA, but they didn't go for good places. Now it has been changed. Now this time, even Peradini, they go. I mean, two people went to. I mean, they secured places in Princeton, and two people to Purdue, that is ranked 5 in engineering. One person, a Hildudian, she secured the place in JHU, in the medical school, but she did computer engineering. She was in my class. She became best of, and that's number one in the world, JHU, medical school. Right? So now people are going to those places. For example, 4 students in our class uh, went to, secured like they had 4 scholarships, free. Everything is free. Even the air ticket is free. Lodging and food, everything is free. One person from even 2 girls from high school, one in 21, she was a rank 1, Achala. In 23, before sitting for A levels, uh, Mihili Herat went to Cornell. Cornell is like in top 10, Ivy League University. And there's another one who was in my online class for some time. He was like Island First, Sahan Samarasinghe. He went to Stanford, right? So if you're interested in, uh, like if you're interested in going someplace like that, the only thing you need to do is to read some articles in English and improve your speed of reading. Then you have to do set, and if you get 3 A's, your chances are really high in securing a place like that. Hmm. Uh, a scholarship is worth like 60 million, no? 60 million to 70 million, right? But I'll do it free, yeah? I don't charge for that, huh? Because I'll give at least one recommendation, then I'll help you how to secure a place like that. Hmm. Uh, right. Now, again, we'll come back to this. Now, in combined math, hmm, uh, we have a little problem, but we don't have it in physics and chemistry, right? Like say you finish O level in this level, in this standard, and you start A levels. However, after 1980, they made mathematics compulsory. So you have to pass it even even to follow art stream. So number of passes should be increased. So there are two things they could do. One is to reduce the pass mark. Second is what? Eliminate the difficult parts from the syllabus. So they did both. Hmm. Now O-level standard has taken below this level, the starting level of A levels. Therefore, there's a gap created due to that. And on the other hand, what we need for A levels is algebra. We don't need geometry, right? We don't need at all. We don't need like shares and stuff like that. We don't need that. Hmm. But we need little bit of probability and stat. Uh, and mainly we need algebra. The only thing you will need from geometry is these two. Midpoint theorem. We need that. The other thing is that the angle subtended by the diameter on the circumference is 90. These are the only two things we need for A-level math. Even without this, you can do it and you can score 99. Because you need these geometrical concepts only to score the last point, 100th point. So without these two, still you can score 99. But without algebra, you cannot score anything. And you have, the training you had in algebra is little, it is insufficient. Therefore, the Minister of Education have introduced some, in the syllabus, they have introduced some basic algebra, concepts of basic algebra for like 18 hours. So we need to go through that. Otherwise, people do these type of stuff, which is in fact wrong. This wrong. Sometimes they do just because of the lack of practice. They forget the term in the middle, 2AB. And sometimes they write this like in the reverse direction, A squared minus B squared. That's also wrong. But in USA or in the Western countries, it's even worse. Because your IQ and the ability in grasping the scientific concepts is extremely high compared to the students in the developed countries. That's why people get PhD opportunities in those countries, because they cannot do the high-end math and physics because they don't have a proper training. They do these type of simplifications. Okay, how do you simplify this? You can factor this. It is a difference between two squares. When x is not equal to a, you can divide. So that is x plus a. This is the right answer, right? But they do it like this. Because x squared divided by x is x. A squared divided by a is a. Minus divided by minus plus. Then they write the answer like that. And if we deduct points for that, hey, I got the correct answer. Give me some partial credits at least. That's what they argue. Okay. Because finally they got the correct answer. It's okay. So if you do something like that, if you do something wrong and get the correct answer, you get 0 marks, huh? Right. So we have to go through basic algebra. I started with elimination of brackets in the single medium class, but I would say we'll start with the next one, because mostly people who are in the English stream, English medium stream, or the English medium students have a better better background in algebra. Therefore, I'll omit that part and I'll straight away start with factorization or factoring. And before that, I'll show you some magic, it's sort of magic kind of something simple, right? I'll show you some division of numbers. But, you don't have to do the same thing. But you have to do something like that in future in the field of like data mining or artificial intelligence, probably machine learning, those type of stuff, right? Probably, you might think, oh, those are kind of really far-fetched ideas, because you simply have go through A levels. You will not even go through, but you will definitely get through it. No, you will develop very quickly in the like forthcoming years, like probably in 7 years. You will do something totally different from what you are doing today, right? Like if I think about my students who were in the class like in 17, 18, now they are doing groundbreaking research, some of them. Now, in probably 6 years or 7 years, you also will do something like that. Hmm. And at the same time, you have the opportunities when you are in the faculty, you can probably um, work like part-time basis and sometimes earn big money, like 2.5 lakhs or something like that. That would be enough, no? Monthly. Those opportunities are there for you these days, which we didn't have those days, right? Okay. But this is something like pertaining to numbers, but you don't have to do this because, now since we have calculators and several machinery, I mean, you can use them to get this. But if you are interested in something, not this, probably say, as I told you, data mining or machine learning or something, uh, possibly, I mean, whatever in your field, if you excel in that field, right? Because if you are interested in that, for sure you can excel in that field. You can be a master in that field, right? Uh, then you will be able to do something that the others cannot do, right? Okay. We'll take this for example. That would be enough. Oh, I'll do something like that if you want to, but there the numbers are a little bigger. Hmm. Okay. You tell me some number. Say something less than 100, right? I'll get to it. Who is going to tell me a number? Just some number. Some number less than 100.
69.
69. You tell me.
25.
25 can be divided by 5. It will make the problem little easier. Give me something.
45. 45.
It can be divided by 5. It's easier then.
That means, should I get less than 100?
No, something less than 100. Ah, 99. Okay. So you gave me two numbers, huh? Pair of numbers. 60, 8, 99. Right? We'll see. Now there are two numbers. We'll see. So this will be the answer. 62 this. I hope it's correct. Huh? Yeah, it's correct. 5. Hmm. No, I'll write this. So it will be a little difficult. Huh? This will be a little difficult. Uh, hmm. It's a little tougher because this has 6 numbers. I think that's correct. I was just worrying about these threes. I think that's correct. Yes. 000333. Uh, like if you spend reasonable time on something like that, not this one, in something in your field, you can do something that others cannot do. Right? Okay. Now, mastering something is not useful now, but long time ago, yes, that may be useful because we didn't have calculators those days. Hmm. Right. Uh, Now we'll start our lesson, na? Factory. Okay. This is this side. It is. Okay. Fact, I would say factors. Sometimes in USA, they call it as factoring. Britain, they call it as factorization. There are that we need to go through two of them. Right. Yeah, we have to go through very basics because some people make some unnecessary mistakes because of the lack of experience. Not that they are not smart, huh? Just due to the lack of experience. These days the points allocated in O levels for algebra is very less, and at the same time the problems appear in the O level paper very simple. I mean the problems in problems pertaining to algebra. That's why we need to go through this. If you have, I'll start with AB, A squared minus B squared. I'll prove this. It's simple thing, but now this is an identity. This is true for any A and B. So to prove this, you have to start from one side. I would start from the right hand side because if you start off with the right hand side, there's something that you need to see. You can simplify. So that's the right hand side. RHS stands for the right hand side. Now expand. You get A squared. Then you get AB. You have minus AB. When you multiply these two, you get minus B squared. These two will go away. It leaves you with A squared minus B squared, which is the left hand side. So that means these two are equal to each other. Now we'll do some examples. Even though you might find that these so simple, but last time with the English medium group, when uh, I asked to do the second problem, I guess in the tutorial, uh, only three of them got the answers correctly. Hmm. So we'll see. I'll start with very simple problems. I can do them here. Hold on. Right. Okay, if you take the very first problem, I mean, in O levels, sometimes you are trained to do it like this, x squared minus 8 squared. But don't do it now like that. We can just treat it as 8 squared. So you can straight away write it like this. Difference times the sum. So x minus 8 times x plus 8. Second, x squared minus 7 squared. So you can treat it as, 7 squared. So you can write it as x minus 7 times x plus 7. But in factorizations, the main thing, no matter what you have there, if you have a common factor at the very first place, you have to pull it out. Can factor the first thing you need to do is to pull out the common factor. Now you will end up with this. Now this is not the final version. Why? This is x squared minus 5 squared. So you can write it like this. X minus 5, x plus 5. In the fourth, again you do the same. There's a common factor. You can divide this by 3 because you can divide this by 9. 1 plus 8 is 9. Therefore, you can divide it by 9. So you pull that out, you get x squared. When you divide this by 3, you get 36. That's the difference between two squares. This is 6 squared. So it will be x minus 6 times x plus 6. Then so you're not waiting for me, you just do it by yourselves, but it's fine as far as you do it right. But if you do the second problem in the tute by yourselves, we'll see whether you actually grasp it or not. Now here, there's no common factor. But using the properties of exponents, when you have a power, now this is 2 squared, this is x squared, 2 squared, x squared. So you can write it like this, 2x quantity squared. You write the square root of this, write the square root of that, take the quantity square. Now it's a difference between two squares because one itself is a square. Now this is 2x minus 1, 2x plus 1. If you do it in one line, that's fine. Nah? You can do it in one line. That's okay. Even this, you can do it in one line as far as you do it right. Now here, both are squares. But if you write it as 2x minus 4 and 2x plus 4, that is wrong. Why? The very first thing you need to do is to pull out, you have to pull out 4. Because that's the common factor. After that, you get x squared minus 4. Now, it's a difference between two squares. This is x minus 2 times x plus 2. Right? Now, the next. Again, you have a common factor. That is 4. Now, you can pull it out. You get x to the power 4. When you divide this by 4, you get 16. This x to the power 4. Now, this is a little too complicated. Now, this is the square of x squared. I mean, you don't have to write it like that. As far as you figure out what it is, you don't have to write this step. Now, difference between two squares. The roots are x squared and 4. Sorry. So, x squared minus 4 times x squared plus 4. So you're not done yet. Why? Because this itself is a difference between two squares. So you further factor that. This is x minus 2 times x plus 2. Right? Now, these are the square roots. So first one goes like x squared minus 4, x squared plus 4. This stays there. This part should be factored like that because it's a difference between two squares. Now here, 6 is a common factor. You pull it out. Now you know what this is. This is the square of y squared. So you can treat it like this. Y squared minus 1 because 1 squared, y squared plus 1. Now this itself is a difference between two squares. So you factor that again. Y minus 1 times y plus 1. But you cannot forget this. Now in this problem, there are a lot of common factors. X squared is a common factor. Y squared is also a common factor. It leaves you with z to the power 4 minus 16. Now we have some experience, right? This is the square of x squared. This is the square of 4. So you can factor that. You have z squared minus 4, z squared plus 4. So this is, this can be factored again. So you have z minus 2, z plus 2. Finally, the last. There are some common factors. 3 is a common factor. X cube is a common factor. So you have to divide this by that. You get x squared minus, this is 9. We have pulled out x cube. You get y squared. This is in fact the square of 3y. Now, this guy itself is a what? This guy itself is a difference between two squares. Now factor that again. X squared minus 3y as from x minus 3y, x plus 3y. Right? Okay. Now you do the second problem in the tube. So as I told you, as I expected, you guys have done a marvelous job. But still, there are some, you know, few mistakes. Only I think couple of you made some mistakes. Others have done a great job. Uh, your exposure to algebra is reasonably good. Huh? But I have to do some, I'll do few examples, few selected examples. In particular, I'll do part Q and R. Right, this is a difference between two squares. Uh, so one, I mean, you can straight away do it like this. X squared plus 2 is the square root of this. The square root of that second term is x. You can just leave it like that, but you can make it look little better. Like you can write it like a, regular quadratic expression like this, so that the powers of x goes down. Oh, if you stop at this level, that's correct. R. Now here, the square root of this is x squared minus 1. The square root of this is 2. I'll write it like this. Now the difference is x squared minus 1 minus 2x. So you have this kind of sugar coating. You know, you can leave it like that, but I just want to eliminate this bracket. Some of you have factored this. I mean, no point of factoring that. Like it is like it is similar to this. Say you have 12 times 8. If you factor this again, like not exactly like that, 2 times 5 plus 2 or something, that's not useful. But if you factor it like 4 times 3 years, that's kind of factoring. If you break this like that, it's not, I mean, there's no use. So if you factor it like x minus 1 times x plus 1, that's not wrong, but you don't have to do that. You can leave it like that. I mean, you can expand, I mean, uh, one of you asked me that, right, right. One of you asked me like this, it's a reasonable question. Uh, can we factor this after simplifying? In this particular problem, no. I mean, that's a reasonable question, right? I mean, one of you asked me like, rather than straight away going for factoring, can we expand it and factor? That approach is good. That's a smart question. However, in this particular problem, you cannot do that. Look, if you try to expand this, for example, you get, I'll straight away write the answer. You get x to the power 4, 2a beta minus 2x squared, right, plus 1 minus 4x squared. So you will end up with this. We don't know how to factor that. Hmm. But if you had plus 1, yes, you can factor it. But with this setup, you cannot factor. Therefore, this approach would be better. But that's a good question, huh? That uh, like rather than factor straight away factoring it, expand and factor. That's also a good approach, but here it fails. You cannot do that. Right. Now we'll go for the next. I mean, your approach, your exposure is really good. I went through almost every answer, not every answer, but almost every answer. Most of you presented very well, and some of you tried to do it in one shot, one line, and you were successful. If you have made some mistakes, I would ask you to do everything like uh, like this. But no, most of you who tried to write the answer in one line got it right. So that's okay. That means you are better than I expected. Right? But if you fail to do that, right, like for example, say if you try to write the answer in one line, and if all the answers are wrong, that means there's no use. But all of you got the answers correct. Correct. I mean, most of you got correct answers. So that's great. Hmm. I mean, in that event, you don't have to like go through intermediate steps as far as you don't make mistakes, right? Now we'll go for the next 1.2. But in A levels, this is a problem you have. Now, as entry level students, you are almost perfect. However, in A levels, the main challenge is not the difficult problems. You don't get difficult problems in A levels because the concepts we go through are really simple, right? In physics, chemistry, and in every subject. However, the problem you have is this. This is something that, I mean, which is really hard to cope up with. You have 1,800 units or hours. Like in the other countries, probably they divide into several parts. Like you do one section, you sit for the exam. You can just forget about that, right? But in A levels, that's not like that. You have to go through everything, and within a short span of time you have to sit for the exam. Like in O levels, even though the number of units is large, uh, the subject matter is so simple. A levels, it's not that simple, even though it's not hard. Right? It's not hard, but it's not that simple. Like for example, say if you have very good background in English, you don't have to prepare for the exam. If you have good background in math, again you don't have to prepare for the exam. There are certain subjects that you need to memorize, like history and stuff like that. Mm. Uh, in A-levels, it's not similar to that. You know, even in the university, say in the medical college or in engineering faculties, usually they prepare for 150 hours of content, like content which is worth 150 hours. But in A-levels, you have to prepare for this much. So that's the toughest thing. It's like, say, your capacity is something like this, say 1,100 hours. When you pour something, part of this will go away. When you learn something like that, you will completely forget something you learned 6 months ago. So that's a problem. So people come up with various strategies. Sometimes they go for paper classes, they go for some group classes, and but the problem is that doesn't help. That if it works, the pass rate should be much more than this, right? Pass rate is like 55% in almost in every science subject. Not in combined math, in everything, right? What's the reason for that? Because the students don't handle the pressure correctly. That's the problem you have. If you are able to handle this pressure, in the smart manner, you can probably all of you have the potential to get 3 A's. At least I would say something more than 3 B's, all of you. But the problem is you get crumbled I mean when you face everything, like when you have to prepare for this subject content. Because the content will be covered like this. Say this first year, second year, probably we have 2 years and 3 months. Subject will be covered like this. Right. So after 2 years, probably no, after 1.5 years, the only 40% will be covered. In the last year, 60% will be covered. Uh, I don't know exactly how the physics, like English medium physics classes go. Like uh, in single medium classes, it is like this. For the first 14 months, mechanics. For the next, probably we have only 26 months, no? 12 months. You have heat, light, yeah, and waves, current, electricity, magnetism, uh, fields, and everything will be radiation will be covered in the last 12 months. So it's like that. Uh, so you should be able to handle that pressure. One method is that you cover the last sections by some means beforehand and prepare those for those sections earlier. That's one approach. Uh, like even in math, you can do something like that. Uh, like three people in 24, 25. No, 1, 2, 3, 4, 5. They did like this. After completing trigonometry, you can digest anything in math. But before that, you cannot. After completing trigonometry, you can understand any concept in math. Before that, you cannot. So those people, once it's covered, they came for the previous class, like say 25 people came to 24 class. And there are five people covered everything 1 year before that. And in fact, two of them sat for the exam. They did really well. I mean, one student who is supposed to sit in 26, did it in 24. And another person who was supposed to sit in 25, sit in 24. They did really well. Both should get reasonable ranks. And this guy wrote O-levels and set for O-levels and A-levels in the same year. Like, still he did reasonably well. Uh, anyway, this is the problem you have, not the difficulty. Like, some people think that, okay, you have to do very difficult problems to prepare for the exam. It's not that. You have to have a summarized knowledge. Because chemistry, in physics, uh, the subject content is little too much. No, you feel like it's too much, right? But it's not exactly the case. So in the last probably 8 months, people get confused because subject content is too much. We don't know what to do. Where to start. So one thing you can do is that when the section is covered, you can go through all the past paper questions, and then you have to redo them. Why? Otherwise, you might forget. Because that's what last time a district first was in our class. Uh, Minidu, he's a Kingswoodian. He did like when he talked to the class last time. What he mentioned was that he went through the past paper questions over and over again. Even though he has done it earlier, he did it again several times, so that just to make sure that he won't forget it. It's usually for a learning process. It's a very, very, very bad process, bad approach anyway. But for A levels, since the subject content is very large, that's a smart way to do it. Usually, doing a problem that you did earlier, hmm, redo a problem, right? So it's you might feel like, why should we do that? 10 minus 5 is 5. Next day, you do 10 minus 5 is 5, like that. You feel it's absurd. But with the subject content you have, that's a smart approach, I guess. Right? Usually, uh, doing a new problem would be better. But the same content is tested in the paper. Therefore, doing weird problems may not help you much. Hmm, that is there. And there's another thing. In the term test papers, they usually ask problems that are not relevant. Right? Uh, so if you try to go through the syllabus and prepare for the term test questions in addition, that will give you an extra burden. Burden like, they will ask like problems from logarithms, which you would hate, right? Because most people don't like logarithms. So, and what else? Logarithms and some sections, those are not tested in the exam. Hmm. Anyway, we'll go for the next 1.2. Difference between sum of, sorry, I mean difference between two cubes and sum of two cubes, both the part A. I'll go for the difference. The factoring can be done like this. Oh, sorry. I'll write the topic first. It goes like this, and I'll give you a shortcut method later. Right. We can start from the right-hand side to prove this. Now you multiply everything by A. A cube, you have A squared B, you have AB squared. After that, you multiply everything by minus B. So minus A squared B minus AB squared minus B cube. So you will end up with this. These two will go away. These two will go away. It leaves you with this. Therefore, since the LHS is equal to the RHS, you can claim that these two are equal. I'll do the next as well. Na? Then I'll give the summary and then we can do problems. B. Sum of two cubes. Let I'll give a summary. I mean, you guys are really good in factoring. I hope the case is the same for the online students as well. Right. Now again, we can, because in the right-hand side, we have to something to deal with. So we'll start with the right-hand side. Later, I'll give you the summary. Now you expand a times this, a cube, a times this. You have a squared b, a times b squared, ab squared. And now multiply this by b, you have a squared b, uh, you have ab squared, you have b cube. Now these two will go away. So you will end up with this, which is the left-hand side. Right? Therefore, you can claim that these two are equal. Right. Now I'll give you the summary. Okay, first you take that down, then I'll give you the summary. difference between two cubes. This is how it goes, right? To obtain the first factor, you close this power exponents. What you see is a minus b. So that will be your first factor. Second factor can be obtained like this. You square the first term, you square the last term, I mean, forget about this negative sign. It's b squared. Then you get the product, that is ab. Similarly, in the second case, you close the exponents. What you see is a plus b. That would be your first factor. Again, do the same, square this, square b square b, and then write the product. It's not 2ab, yeah? It's ab. Now, we have this. If in the first factor, the sign, look what happens to the sign. Sign alternates, plus to minus, plus minus. If it happens in one factor, you keep the other factor in such a way that the sign doesn't change. Now here the sign alternates, here sign is fixed. Now in the second case, sign is fixed. Therefore, in the second factor, you have to alternate the sign, plus, minus, plus. So plus, minus, plus. Like if you want to factor something like this, yeah. I'll do a couple of examples and then I'll let you do the problems in the tute. Now, your preparedness is good now. I mean, uh, but only, I mean, in the single medium class, I didn't, apart from 3 students, others need some exposure. But in your case, it's different. Everybody has like reasonably good exposure, and the way you present the answers are very good. Everybody. I didn't see any. The only thing I saw is that most of you try to write the answer in one shot, in one line. But still you succeeded. Now the answers are correct. Therefore, I don't have any problem with that. Now, we'll see some more problems. These are difference between two cubes. Right. In this case, it is 3 cube. If you treat it as 3 cube, you can straight away factor it. If you want, there's no harm in writing like this, but it's not a must. Huh? You don't have to introduce it. But just to show this shape, I would like to do it like that, but you don't have to do it in that way. Now look, you close these exponents. So what you see is x minus 3. So in the second factor, you square this. You square 3, which is 9. Then you write the product. Here the signs alternate. Here signs should be fixed. This is x cube. Again, the laws of exponents will give you that, okay, you write the cubic root here. It is 2. You write the cubic root of y. Now factor. Close the exponent. What you see is x minus 2y. X minus 2y. In the second factor, you get x squared. When you square this, you get 4y squared. 2y times 2y. Then write the product, 2xy, these two. Now signs should be fixed. Now, no matter what the problem is, if you have a common factor, you have to pull it out. 4 is the common factor. X cube minus 8. 8 is in fact 2 cube, right? X cube minus 8. I can write this 8 and then write 2 cube. I mean, this step is not compulsory, yeah? But I just want to explain how it occurs. Therefore, I just wrote it like this. Now, close these exponents. What you see is x minus 2. So that should be your first factor. The second factor, you square this, you get x squared, you square 2, you get 4. Then you multiply these two with ignoring the sign, you get 2x. Now keep the signs fixed. This one. X cube is a common factor, you have to pull it out. You can write this 8y cube as the cube of 2y. Now, when you close this, what you see is 2y minus z or z. How do you want me to call it? Like some people, in particular those international people from international school or people in abroad, they usually call it as z. But here people prefer it as z. In Jaffna, they call it as sad. In Bangladesh, they call it as how? In Bangladesh, how do you call this? Okay, how do they pronounce this? Because 20 years back, the only country that Bangladesh can sometimes beat is Zimbabwe. Usually, we have a friend from Bangladesh, so he usually once they win the match, they usually shout in like exhilaration, "No, man, we today beat Zimbabwe." They call it as Zimbabwe because they cannot pronounce Z. This is Jew. We went to the Jew, or we went to Jew, and they call it like that. So for them, it is like I don't know. Is it judo something? I don't know how they call. Is it Z should be sorry? Z should be G or something like that for them, right? Anyway, we'll call it instead Z. So we'll square this now. Square this, you get 4y squared. You square this Z squared. Now write the product 2y Z. And here signs alternate. Here you keep the signs fixed. I'll do some few sum of the squares. Right. Right. Here 8 is a common factor. You get x cube plus 8. Now 8 is 2 cube. Now close the exponents. What you see is x plus 2. Now, to create the next factor, you square this, you square 2 and get the product. Now, here signs are fixed. So, in the second factor, you have to alternate the sign, plus, minus, plus. Here you can see that x cube is a common factor. You get 27y to the power 6 plus 1. This is a cube of what? You have to write the cubic roots of both terms. This is 3, this is y squared. If you want, you can write this as 1 cube. And this step is not a must. I just want to show you how you create the first factor. You close this, you get 3y squared plus 1 when you close these two. Ignore those two. Now the second factor can be created like this. You square this. When you square this, you have to square each and every term in the product. So you get 9y to the power 4. This is 1. This is the product of these two. You get 3y squared. Since this sign is positive, since the signs remain intact, here you have to alternate the signs like this. Right? Now, do the third problem. Okay, we can wind up with these problems. I think you don't have any problem with parts A, B, and C. I'll do part D. There's a little problem. Huh? There was some three easy problems. I deleted that, but I have forgotten to change the problem numbers. After ABC, you have G, H, I. So I use the same numbers. Huh? G means actually the fourth one. Right. You can pull out two. I usually insert extra steps, just for the sake of clarity. But you can, if possible, you write the answer in one line. That's okay. Now, this is in fact 2y quantity squared, 2y quantity cube. Because this is the cubic root, the cubic root of 8 is 2. Cubic root of y cube is y. Now, close these two exponents, you get the first term. To get the second term, you square this. You square 2y, you get 4y squared. Then the product of these two will be 2xy. That is, now, here the sign has been changed. Here sign should be fixed. Right? H. Should I do H? We'll see. No, H is not difficult. I'll do I. There you have alpha to the power 6. Now, one of you tried to do something like this. He wanted to take this as like difference between two squares. But you cannot do that because there's a plus sign. But if you have a negative sign, you can take it as difference between two squares. But here you cannot. Now you can write it like this. This is a cube of alpha squared. This is a cube of beta squared, gamma squared. The cubic root of beta to the power 6 is this. The cubic root of gamma to the power 6 is gamma squared. Now close these cubes. You get the very first factor. You get alpha squared plus beta squared, gamma squared. In the second factor, you have to square this. Then you have to square this. That means you have to raise each and every term to its square. Right? It is like this. Sorry. If you want to get the square of a product, you have to raise each and every term to its square. This is, you have beta to the power 4, gamma to the power 4. In between, you get the product of these two. Here, since the sign is fixed, in the second factor, the sign should alternate like this. Right? I'll do J. Here you have to pull out the common factors. 9 is common, x cube is common, y cube is common. You will end up with this. Now this is xy quantity cube. One can be written as 1 cube, but it's not a must. Huh? I just want to show you how the first factor is obtained. The first factor can be obtained by ignoring these cubes. You get xy minus 1. In the second factor, you have to square this. So raise each and every term in the product to its square. 1 squared is 1. In between, you get the product. Now, here the sign alternates. Therefore, in the second factor, you have to keep the sign intact. And some of you, very smart guys, huh? But still they ended up with incomplete answers, not wrong answers. Incomplete answers because they try to do it in one line. That's why I told you. When you try to do it in one line, you have to think a lot. Probably the amount you write may be little less, but it has its own disadvantage. Yeah? Because, if you try to shorten the answer too much, you feel like, okay, I have answered it in the smartest way. But in fact, it is not. The reason is when you do a 3-hour paper, if you try to do it like that, it makes you little like it makes you very tired towards the end. If you try to shorten things, I could remember that there's one guy, one Trinity, who was in my class in 16. He had a little game. That's very interesting. But there's a bar, right, like this. It gets shortened within, I say, in 10 seconds. You have to do some like mathematical problems on top of your head. Not very difficult ones, like this, subtracted by, let's say, something like this. And 0.38 times 0.95. Those type of problems. But you have to answer them within 10 seconds. If you give the answer faster, you get more points, like that. So when you play the game, like after, I would say 5 minutes, you get really tired. You don't see what these numbers are towards the end. Because you do a lot of calculations in real quick. If you try to do that, you get tired. That's what happens to most of people. They in the A-levels, they are more concerned in timing rather than doing the problems correctly. Like it's like a marathon, we have to keep our stamina. If you try to shorten the answers too much, what happens is that towards the end, you feel tired. You don't actually feel it. You are actually mentally tired. So what happens is then when you read a problem, you read some stuff like you missed some important points, like radius is read as a diameter. It's understood as a diameter. So at the beginning, you write something, you write a different problem and do something entirely wrong. You better shorten some stuff, but if you try to shorten everything, you might lose some points. Not for the steps. Towards the end, you do something else because you are tired. You don't feel it. It's like they say you run a marathon. So what's the technique? You have to always keep it with the bunch. Like if you try too fast at the beginning, finally you cannot win. That's there. You have to keep your stamina. This is the mental stamina. Like if you get tired, finally towards the end you cannot score points. But if you keep your stamina in the paper, like you have to use first 1.5 for probably half an hour to warm you up. After that, you can go real fast, right? And you don't actually feel it. It is exactly like the marathon. You can sprint in a marathon towards the end, not at the beginning, right? Okay, so it's exactly like that. Knowledge is one thing. Writing, I mean, getting successful results in an exam is not exactly that. On top of knowledge, you need to know the strategy to score the best. And most of you have that. Huh? I don't say that you don't have it. But if you try to shorten the answers all the time, you might run into problems. Right? But you don't have to give long answers. But if you try to jump, lot of steps, probably it might make you a little tired. Hmm? You have to avoid that. Right? This J. What else? I mean, you can do the rest. I'll do J, last one. KLL. I'll do the last one. L. You pull out 8. 8 is the common factor. You get 8 x to the power 6, y to the power 6 minus 1. It's a cube of, sorry, it's a cube of something. It's a cube of 2 x squared y squared. Now you can write the very first factor. 2 x squared y squared minus 1. Right? The second factor will be, you square this, so you get 4 x to the power 4, y to the power 4. When you square 1, you get 1. Then you write the product. It is 2x cube y cube. Here the sign alternates. Here you have to keep the sign fixed. Right. Probably next week also we can meet at the same time. Later probably we can move the class to our usual time after New Year. I'm happy with your work. Huh? It's great. At the beginning, I mean, most of you, all of you, know how to how to give some answers. You know, sometimes students write the way that they don't get marks. I mean, your answers are really clear. Very good. So we'll next time, you know, we have to spend some time. This kind of an investment. I mean, say for example, we have like 10 guys who have some problems with algebra. You know, when we go on a trip, the speed of say when we say hike, go for a hike, the speed depends, the pace depends on the slowest one, right? That's why. So we have to spend some time to get those things up, and then we can move. I mean, we don't have to go faster, but we can go through things little quicker if the lowest level is reasonable, right? So that's the effort for this. So we probably have to spend like at most couple of days. Then we can start functions. I mean number systems and then functions. Hmm. We can get into real stuff as quickly as possible, but we have to spend a couple of days in brushing up these things. But I don't have to spend more time like in a single medium class. We can move a little quicker. You guys are good. Right. So I'll see you next week at the same time. If you change the time, we can probably move to AC room, like in the downstairs, main hall, right? But next week probably we can meet in the same place. Week after the next, I think it will be a holiday, New Year. But after that, in the following week, probably we can meet at the regular time, like 2:30 or something like that. Even after school, we can have that time, 2:30 or 3 to 6, like that. Okay. So I'll see you next week.